Today we're going to practice writing an equation for a line from 2 points. So let's get started. So here we have a line and it goes through the points 2, -5 and 4, -1. We would like to write an equation for this line. So what do we know? Well, we know 2 points. But what do we want? Well, we want to write an equation for this line. It doesn't say what form. So let's write this in point-slope form. So in order to write an equation of a line in point-slope form, well, we need a point, any point that's on the line, and the slope of the line. Well, we do have a point. We have 2 points. But how about that slope? Remember, we can find the slope of a line from 2 points. We're going to take the difference, the change in y, over the change in x. So this is our rise over our run. And from these 2 points, we would end up with a slope of 2. So now we know the slope of the line, and we have a point. I went ahead and just picked the first point listed, but we can also use the second point as well. Now, in a previous lesson, we took the slope of a line and a point, and we plugged it back into that slope-intercept form and found the y-intercept. And then once we had that y-intercept, we were able to find the equation of a line in slope-intercept form. And I'll put a link to that video in the description. But let's look at another way. So in this case, we're going to use that point-slope form. Again, we do know a point, x1, y1. I'll use 2, -5. And we know the slope, too. We can plug those values in. So we now have an equation in point-slope form. And then we can convert this to slope-intercept if needed. So let's practice using this method to find the equation of a line when given 2 points. So in this example, we're going to use the point-slope form to write an equation for the line that goes to the points -1, 7 and 2, -2. And then once we have this equation, we're going to rewrite it in slope-intercept form. So at point-slope form, we have y minus y1 equal to m times x minus x1. So we need a point that is on that line, and we need the slope of that line. Well, we have a point. Again, we do have 2 points. So let's find that slope. So slope is equal to y2 minus y1 all over x2 minus x1. So y2 is -2 minus 7 all over 2 minus a -1. We now have -9 all over a +3. And this is equal to -3. So the slope is equal to -3. So now let's write this equation using that point-slope form. For right now, I'll go ahead and take this first point that we have listed. This will give us y minus 7 equal to -3 times x minus a -1. So there is an equation in point-slope form. I will simplify this equation to get rid of this subtraction of a negative. So we have y minus 7 equal to -3 x plus 1. And so this is an equation of that line in point-slope form. Now we're going to convert this to slope-intercept. So I'm going to rewrite the equation. We have y minus 7 equal to -3 x plus 1. And we want to write this in slope-intercept form. So that's y equal to mx plus b. So the first thing we're going to do is use that distributive property and multiply that negative 3 times the quantity x plus 1. So we have y minus 7 equal to negative 3x minus 3. And then adding 7 to both sides, we end up with y equal to negative 3x plus 4. And this is our equation in slope-intercept form. Now we're going to practice writing the equation of a line from 2 points. And we're going to use 2 different methods. First, we're going to use that point-slope form, which we just practiced. And then we'll use that slope-intercept form, which we practiced a few lessons ago. And again, I'll put a link to that in the description. Either way, if you want to write an equation of a line from 2 points, you're going to need to find the slope of that line. So let's start by finding the slope. So the slope, well, that's equal to the change in y, so y sub 2 minus y sub 1, all over the change in x of 2 minus x of 1. So in the numerator, our change in y, we're going to have 6 minus 3 all over, and then in the denominator, we'll have 4 minus a negative 2. This gives us 3 all over 6, and 3/6 simplifies down to 1/2. So our slope, m, is equal to 1/2. So let's start with that point-slope form first. So when we're talking about point-slope, the equation for that is y minus y sub 1 equal to m times the quantity x minus x of 1. Again, it doesn't matter which point you pick, but I'm going to go ahead and pick the second point this time. That way I'm not subtracting negatives anymore, since both of those numbers are positive. This will give us y minus 6 equal to 1/2 times the quantity x minus 4. And so we now have an equation in point-slope form. But let's go ahead and convert this to slope-intercept as well. So we'll start by distributing this 1/2, getting rid of the parentheses. So we have y minus 6 equal to 1/2 x minus 2. And then to get the y by itself, we're going to add 6, and we'll do that to both sides. And we end up with y equal to 1/2 x plus 4. And there's our equation in slope-intercept form. Now let's solve the problem using the slope-intercept method. Again, you only need to do one of these, but we're just going to practice both for this problem. So the slope-intercept, that's y equal to mx plus b. So we know the slope m, but we don't know the y-intercept. Neither of these points are the y-intercept. But we do have a point. We have 2 points. And we can substitute those in for the ordered pair x, y. Again, I'll use this second point. So instead of y, we're going to have a 6 equal to 1/2. And then x will be replaced with 4 plus b. And now we're going to solve for b. This is 6 equal to 2 plus b. Subtract 2 from both sides. And we have b equal to 4. So we know the slope. We know the y-intercept. So we can write this in slope-intercept form. Y equal to 1/2 x plus 4. It does not matter which method you use. I almost always choose to use the point-slope method. But for right now, you should practice with both of them and decide which one you like the best. Let's try two more. And for each of these pairs of points, we're going to use that point-slope form. So in this case, practice with that point-slope form and write an equation of a line that contains the given pair of points. And then after you have it written in point-slope form, rewrite the equation in slope-intercept form. So the point-slope form, that's y minus y sub 1 equal to the slope times x minus x of 1. So we're going to need a point and that slope. Let's start with the slope. So the slope, that's equal to the change in y all over the change in x. So in the numerator, we're going to have 8 minus a negative 4 all over 4 minus a negative 12. This will give us 12 all over 16. And we can simplify this down to 3/4. So our slope is 3/4. So now we have a point, 2 points actually, and the slope. So let's go ahead and use that point-slope form. I'm going to again use this second point because it doesn't have negative numbers. So now we have y minus 8 equal to 3/4 times x minus 4. So here is an equation in point-slope form. Now let's convert this to slope-intercept. We'll start by distributing this 3/4. So we have y minus 8 equal to 3/4 x minus, and then we have 3/4 times 4 over 1. So this is y minus 8 equal to 3/4 x. These 4's are going to cancel out. It's going to leave us with 3 over 1, or 3. And then to get rid of this negative 8 on the left, we'll add 8 to both sides. And we end up with y equal to 3/4 x plus 5. Let's look at this second problem. We have the points negative 4, 2, and 20, 20. Again, we're going to use that point-slope method. So y minus y sub 1 equal to the slope times x minus x of 1. Again, we need both a point, this x of 1, y sub 1, and we need the slope. We already have a point. We have 2 points. So let's find that slope. So the slope is equal to the change in y, so y sub 2 minus y sub 1, all over x of 2 minus x of 1. This is equal to 20 minus 2, all over 20 minus a negative 4. This will give us 18 all over 24. And this simplifies down to 3/4. So the slope in this case is also 3/4. So now let's write an equation. And in this case, I'm going to use this first point because the numbers are a bit smaller. So we have y minus 2 equal to 3/4 times x minus a negative 4. Then we could rewrite this as y minus 2 equal to 3/4 times x plus 4. And so there's our equation in point-slope form. Now let's rewrite this in slope-intercept. We'll first multiply this 3/4 to the quantity x plus 4. We get y minus 2 equal to 3/4 x plus 3/4 times 4 over 1. Again, these 4's will cancel out. We have y minus 2 equal to 3/4 x plus 3. And then adding 2 to both sides, we get y equal to 3/4 x plus 5. These are the same equations. Y equal to 3/4 x plus 5. So this pair of points produce the same equation as the second pair of points. These 4 points all lie on the same line. So although y minus 8 equal to 3/4 x minus 3, well, that looks different than y minus 2 equal to 3/4 x plus 3, but those are the same line. So it's difficult to tell if a line is the same when written in point-slope form. You can write a different equation for every point that's on the line. But when you rewrite it in slope-intercept form, we can see that those lines are the same. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 2 problems. So we're going to use that point-slope form to write an equation that contains this pair of points, and then we'll rewrite the equation in slope-intercept form. So to use that point-slope form, we need a point that's on the line. We have 2 of them. And we need the slope. So let's first find that slope. In this case, we get a slope of 2. Plugging that into the point-slope form, and then depending on which point you picked, here are 2 point-slope forms of that line. And then I rewrote this second equation into slope-intercept form and ended up with y equal to 2x plus 2. And then the same process for this second problem. So we'll use point-slope form at the start to write an equation of a line that contains the given pair of points. And then we'll rewrite this equation in slope-intercept form. To use point-slope, we need a point and the slope. We're given 2 points, and we can calculate the slope from those 2 points. We end up with a slope of 5/2. Using that point and slope form, and then depending on which point you picked, you'll get one of these 2 equations in point-slope form. In this case, I took that first equation and rewrote that in slope-intercept form, and this results in y equal to 5/2 x minus 20. Drop any questions you have in the comments. Continue practicing writing the equations of a line from 2 points, and I'll see you in the next video.